Okay, looking at this, I do not recognize its antiderivative. So I'm going to say U substitution is probably not going to help me out. Integration by parts is about the only way I can really go here. So I'm going to say U equals the arc secant of x. That forces me to say that the dv is equal to dx. That means x equals v. Constant integration we'll worry about later. This over here, du, that's an easy part. And the derivative of arc secant is going to be minus, and again, if you can remember this, great. If not, you have to derive it. 1 over x root of x squared minus 1 dx. All right? Now, granted, that ability I can write that down doesn't mean I can make it any easier for me to do the problem. Let's put this down, and you're going to get minus x. I'm using uv, right? So minus, not minus x, I'm sorry, x times arc secant and again minus a minus a plus. It's going to be let's see, v du, which can be this over here. All right. Did it get easier? Somewhat. Not substantially, though. Again, this was, I didn't know it. This over here, I'm not knowing that either. But I do know something. I know I can make a substitution now. Right, I'm going to do the trig substitution now. And the trig substitution I'm going to do is I'm going to let x equal the secant of theta. And that means the dx is going to be secant theta tan theta d theta. Let's plug it in. And what do you get? X arc secant and we're getting something we're kind of mixing things here, but let's not worry too much about that yet. Let's see if this goes anywhere. So what do you get? You're going to get, let's see, the dx is secant theta tan theta d theta, and the root of that, what's going to be secant squared theta minus 1, which is the tangent squared theta, and in the invertible region, the square root of that is going to be tangent of theta. Not so bad. So what do you get over here? You get x arc secant of x plus, well, it looks like you just get a pretty simple integration now. And again, it seems like the theme of this thing is secant keeps popping up. And what's it going to be? X arc secant of x plus the natural log secant theta plus tan theta plus c. And that's going to be, I got to clean that up a little bit. And let's write this down. X arc secant of x plus the natural log. And I got to clean this thing up now. And let's break this down. So x is the secant of theta, so I can write that down. It's pretty simple. And then let's just over here. Sorry about that. Let me get my little triangle down. I got the theta over here, and let's see. The secant of theta is x over 1. Put that down here. And let's see what you get for the the side opposite theta. That'd be the root of, let's see, x squared minus 1. I can do the tangent, just simply the root of x squared minus 1. I can put a box in this. I'm going to commit to that. Get my red pen out. I'm looking at the answer here and the answer here, and I want to see if they're equivalent. X arc secant of x plus the natural log of x plus, yeah, we did it right, all right? Now it goes on to say you may recognize. Now you may recognize it. You may not recognize it. You may say, I can't recognize that. And again, if you did that, I guess we could rewrite this a little differently, but there's no need to. If you want to, you can, right? What I mean by that, if you recognize this, you could write that down instead if you like. Thank you.